Hi, I'm Jason Jelks, Manager of Software Development at Sensory Analytics. In this video series, we are going to discuss setting up the SpecMetrix system using the SA configuration tool. Starting in SA 3.3, we have simplified the process for configuring a SpecMetrix traversing beam. The way you want to do that, of course, if this is a SpecMetrix traversing beam with the PLC, we will have a controller type that is PLC integrated, and it is connecting and communicating through that controller through the Kepler OPC process. So you would also want to make sure that you are connected to the Kepler EXV6, which you would basically be able to find by selecting local machine, browsing to your Kepler 6, and then selecting OK. Once you have that information established, by default, everything that our traversing system is measuring in is in millimeters. However, screen displays may come back in inches, and so if you need to go in inches, you can simply select inches, and you will see that the roller width, home offset, and calibrate position will recalculate into inches. Everything as far as our process in the PLC is always in millimeters. For right now, we're going to do this demonstration showing as millimeters. So the way we would set up a traversing beam is we will simply click on the train traverse icon here. Move this in for you. And what this is going to do is kind of connect up and let you know the distance it is from its home offset and hard stops. So clicking on the start button here, what that will do is it will cause the probe to do what's called a home to torque. That means it is going to move the probe all the way to the home or negative side of the beam until it experiences a torque limit, and then it will move itself off by a number of millimeters, which would be equivalent to this home side safe stop. And it's roughly within plus or minus 1 millimeter of that stop. What we need to do now is we can set our adjustment speed based upon how fast we need to move or adjust this speed. If we wanted to make sure we can move quickly, we can set it up to 100 millimeters per second, or down to say 10 millimeters per second at the slowest. And that would allow you to slowly move the probe across if you're really trying to need to get some sort of pinpoint alignment or be careful around some particular materials. Using the jog right and holding it, or jog left and holding it, allows you to move the probe in either direction and get you the ability to kind of zone in on a particular position. Alternatively, you'll see that we are in a move to in mm for millimeters. Otherwise, it might be an IN if you're in inches. And I can type in a number of millimeters here. If I wanted to move out 200 millimeters, I'd type in 200 and then click on the move to. And as you can see, I've now moved to approximately 200 millimeters. And then if I want to set any of the locations that are defined for our positioning, of course, the home side safe stop and far side safe stop respectively are the very outermost limits, and nothing can be set beyond those because that's where the motion limit is going to be defined. The park location must be on the negative side of the home side of the probe. So that can be anywhere you want and set any position as long as it is greater than your home side safe stop. We're at 87. I will just simply click on park location, and I will see that the position automatically transfers down. For our calibrate location, that is a position that is accessible by the user to be able to put on the black TVU for them to set up a calibration test and make sure that everything is looking good. It does not matter where that is. It can be on the home side, can be on the far side, wherever they want to put that, whatever's convenient. They simply click on the calibrate location with a left click, and that will assign it. The next thing that they're going to do is they're going to move the probe head until the center of the probe is lined up directly with the edge of their physical roller on that machine. We're setting up a physical machine on a physical machine. This is not setting up to a web that may have different sizes. So we want to get to the physical limit of where a material can possibly be made or reach to. We will then click on set the home side edge. We will want to move at least halfway, usually a little bit for maybe 60 to 70% away across our roller. And just pick a point at which, if we did not encounter any web material, that this would shortcut the process and give us an indication that there was no web to detect. Click on the no web detection, and that will assign that position. We can then continue on, and again, when we get to the far side of the roller and the center of the probe is at the edge of the roller, we want to assign the far side roller edge. Click on that. And then we want to make sure that we can get out at least another 50 millimeters or so for some adjustment. We ideally want to be 50 millimeters from the edge of where the machine will actually hit the side of a physical limit, and that way we will protect the machine. It will not allow it to travel at high velocity into the edge and smash up against the sides. Once we have those values and positions, we can click on the far side safe stop. After that, we can click on finish. We will answer yes, that we want to complete this total travel, and it will complete by going on in a safe speed and reach the limit of the edge of that particular beam, and then it will make its way back. And as it's coming back, it's going to move itself to about 50 millimeters from the edge and perform a final home to torque. What that final home to torque will do is it will move the probe out to the home side roller edge, which is redefined as the new zero position. Therefore, the home side safe stop, the park location would all become negative in respect to that value. And all of that information is calculated and held internally. So we can see that here where all these values are stored. We've got our roller width that's automatically calculated, our total travel limit that's automatically calculated. There is no need to measure anything physically. You can do all of this with this new tool. Once this is completed and you have that done, the last step is to go up, file, and save. If you do have a second beam, you will want to do this also for the second beam. And again, keep in mind, you do want to save your changes afterwards. Once you've completed that, you can close this down. If we are in a hardware state that is running, in other words, our hardware connection status is green, we will need to temporarily turn that off. And then once that has had its moment to shut down, we will want to turn that back on. And that will finalize our process, and we are then ready to run. It is a point to note that with the new software version, anytime the system is getting the hardware initialized for traversing systems, it will perform and execute a homing routine, which will move both probes or all the probes attached all the way to their home to torque position and then back out to their zero position, so that they are confirmed, ready with distance and measurement, and can move from there. Secondary final note to point on this is you can no longer just copy a configuration from one system to another and not go through the process of actually having to set up traversing anymore. The traversing really is very specific now from system to system, and so you do want to make sure you're not copying secondary systems over and trying to circumvent a shortcut process, because the dimensions of the beams, where they're mounted, how they're associated in respect to the rollers and other hardware may be very different. Thank you. Have a great day.